Tēnā koutou, tēnā koutou, tēnā koutou katoa. Welcome to the SOLA seminar series at Lincoln University. Today we have a research topic and we have Dr. Gillian Lawson, who is Associate Professor and Head of School at the School of Landscape Architecture at Lincoln University. Today, Jill is going to talk to us about visualization and pedagogy in landscape architecture, mainly tackling the importance and the impacts of the advancement of technology on teaching and on the discipline as a whole and the practice itself. And she will address the following question: can technology facilitate not just the transfer of knowledge, but a shift in perspective? So welcome, Jill, and thank you for accepting my invitation. So the floor is yours, and for those of you who are joining us, please use the Q&A button to post your questions. You can ask them during the presentation, and we will address them at the end of Jill's talk. You can also wait until the end to ask your question or questions. So thank you again for joining us, and Jill, the floor is yours.
Thanks, Nada. Thanks for the invitation to speak to you today. I've chosen visualization and pedagogy to talk to you about because both these topics are something that really interests me, not just in landscape architecture, but hopefully it interests my audience today as well. So just going to change my slide.
You might need to click on your PowerPoint.
Yeah, all good. So visualization to me means something perhaps a little bit different to you. Visualization for me is the ability to form a mental image of something so that we get an internal shift or a change in perspective or a different way of seeing something. This is often used synonymously with the term visual representation, which is more about how we depict multiple dimensions of landscapes through analog or digital methods. Pedagogy is often thought of in terms of the act of teaching. For me, it's the study of how knowledge and skills are imparted through social interaction, particularly in an educational setting. Social interaction, for those of us that have studied sociology, isn't just about face-to-face talking or using a screen to communicate with other people. It's also about visualization and representation of what we think in our heads is something that makes sense to us and other people. The problem that I'm interested in is the struggle that we have often with change. And this happens a lot in educational settings, particularly with students who are having to shift from one context to another all the time. And so change for them, and for many of us, is quite a difficult thing. I started in this area looking at Basil Bernstein's theoretical concept of pedagogic code, and I want to go back to a model that I developed some years ago and walk you through some different positions that we could think of in terms of how we see pedagogy in the educational settings. I'm going to go through a little bit about drawings and still images that we are generally pretty comfortable with. Some of the work that I've done on videography and moving images, and then finally some dabblings in virtual reality, augmented reality and mixed reality, which is still really in its infancy, certainly in the educational context. And then I want to go back to the model that I introduced earlier in this lecture about looking at how some of these representational tools could be used to maybe predict changes in the pedagogic code in a changing visual world. So many of us struggle with change because we have to learn to do things differently, and this then allows us to adapt to changing circumstances. And we can understand this through the theory of teaching and or the theory of learning and or the nature of knowledge itself. And it's the last one that I'm particularly interested in, is knowledge theory. Simon Bell, in one of his books, had a really interesting drawing or diagram that it kind of inspired me to think about knowledge in terms of the drawings or the diagrams that you see to the right of your screen. If you conceptualize knowledge as being open arcs that have some sort of boundedness or boundaries around them, open-ended because, you know, our knowledge is fluid and we can't always predict a clear boundary around the whole thing, but we can certainly know when we shift out of our boundaries of knowledge. And if we work in a team, this often requires us to see how our knowledge boundaries of each person overlap. So that if you look at the top right-hand diagram, you see where knowledge boundaries overlap, and each of us in that team can actually explore what I call the decision space for creative opportunities to solve problems or adapt to a new situation. If you go down to the bottom right-hand corner, this is where, if our knowledge boundaries are quite rigid and we don't see the need to change, and we have these points of contention, which is where we don't want to shift, we kind of have a set way of doing something, then our decision space is constrained. Whereas if our knowledge boundaries in the bottom right-hand corner are flexible and elastic, then our decision space expands and we can develop a decision space that's much larger to create creative solutions and make more innovative decisions about changing circumstances. So this is what allows us to be creative and adaptable in new circumstances. The pedagogic code studies that I started some years ago started with looking at how students represent their understanding of a particular concept that they're being taught. And in this case, it was landscape planning that I was teaching for quite a long time. They struggled coming from the design studio into landscape planning with all sorts of issues. And I thought, of course, the first thing that you think when you're a teacher is it must be your fault because you must be a poor teacher for some reason. But actually, as I started to read theory and educational philosophy, I started to develop this concept of pedagogic code after I was reading Bernsteinian theory. And Bernstein talks about the concept of classification and framing as constructing this pedagogic code, which is very context specific. So these are just 4 examples of some of the student drawings that I had. And I asked the students to draw their concept planning at the beginning of the semester and at the end of the semester so that I could compare what the pedagogic positions of these students would have been before and after the course that they did. So along the horizontal axis, you'll see the framing, and at one end, at the right-hand end, there's very little discretionary space for students to actually make their own choice of how they learn. Whereas at the other end of the horizontal axis, there is substantial discretionary space for them to choose how they learn. If you look at the vertical axis at the top, this is how we identify as professionals. So this is based on professional knowledge and how we do things as a particular group within society. Whereas at the bottom of the vertical axis, classification here is about you as people in general or citizens in a society. And so I developed a way of coding these different drawings to be able to showcase all of these different positions. And this is how I came up with a model for curriculum design. And I've got each of these 4 quadrants actually illustrates different positioning of teachers and students. Now, each quadrant you can actually divide again into four more quadrants. And so you can go down deeper and deeper into this. But for simplicity's sake, let's start with the top right-hand quadrant, which positions the teacher in relation to the content, which is about specific operations and local skills that are relevant to their professional development. So the teacher is positioned as instructor, and the students expect or are expected to show norms of observable professional behaviour. If we go to the top left-hand side, things shift a little bit in terms of students being able to get enough a chance to actually progress at their own pace. So this is about focus on self-progression, and the teacher here is positioned as facilitator, and the students are expected to show some sort of capacity. In landscape architecture, some people believe that being able to design is an innate capacity, and so this is where that argument or debate goes on. If we go down to the bottom right-hand quadrant, we see where the focus is on how we're positioned within a broader group, within a community group or within society. And here the students are expected to show evidence of their own decision making for the outcomes that of what they actually choose to know. But here the teacher acts as a guide because they take the students through a sequence of how to learn, so that the students can make decisions themselves about what they end up learning and what their knowledge outcomes end up being. On the left-hand side, on the bottom quadrant, we see here a focus on self-empowerment and reflection. So this teacher here acts as provocateur, and the students are expected to show evidence of new dimensions of themselves and others. So they have completely free choice of what they learn and how they learn it. So this gives you a bit of an overview of kind of the theoretical thinking that has kind of influenced how I see curriculum design. Now, students and teachers can shift around in any of these quadrants at any particular time. But when I looked at the drawing data, I found that overall there was a general shift from the top right to the bottom left. And although there's no particular quadrant and positioning is either correct or incorrect, it was very interesting to actually see this in the data to show this shift in kind of thinking. Looking at the technology then, this is where we start to see, if we go back to 1969 when Lincoln University set up its accredited landscape architecture program, we see in the 80s and 90s there was a lot of development of representational tools being ending up releasing commercial projects or products that were very influential on landscape architecture. So we had the World Wide Web being developed in the 1990s, which led to, in the 2000s, Google Earth being released. Then we had the smartphone being released and connected into a 3G network for the first time. We had cloud computing being used. We had the release of the iPhone by Steve Jobs at Apple. We had Oculus Rift. We had UAVs and drones being developed and controlled via Wi-Fi. We had Minecraft, which was the highest grossing video game ever, where the player had a greater discretionary space over the creative decisions to complete the tasks in the game. And then we had Pokemon Go, which was the augmented reality mobile game that was hugely popular around the world, where GPS could actually locate virtual creatures in the real world. And then we had computer vision and machine learning technology, or AI, being released through the Phantom 4 drone. And now, of course, this year we've got the 5G, the 5th generation cellular network, which should make web-based interactions a lot faster for all of us. So what I'm going to go through is some of the work that we've done with drawings and still images with students. And that's familiar with for most of us, I think. And then I'm going to go on and look at videography and moving images. And then some of the dabblings that we've started to use virtual reality, augmented reality and mixed reality with in the classroom. So freehand and digital representation of site conditions isn't anything new to most of us that are teaching landscape architecture in universities. So on the left is Lucia's freehand drawings, which we really tried to encourage. Now, a lot of students don't like using their freehand graphics. They don't feel confident with it. Most of them look at what's generated by computer graphics on the right, which is Sarah's work, seeing this beautiful representation of spaces in a very clean and crisp format. Now, the exercise that I gave these students was to go out into an urban space and look at the distances and the dimensions of things that create the experience of that space first, and then come back to the classroom and document the sort of detail that they need at 3 different scales. Now, what's happening here is that we're focusing on their professional development, their professional skills and knowledge to actually empower them so that when they go out into the workforce, they will be able to use these without really being too concerned about it. And I think what's happening here is the teacher is being positioned as instructor, and the students are being asked or expect to be asked to demonstrate these observable norms for professional practice in landscape architecture. Now, if we go on to some work that I did with a former PhD student of mine, he was working on visual assessment in the urban environment of Brisbane City. And he looked at hundreds of court cases in the Planning and Environment Court, and he started with some selected cases with photo montage work, which is very commonly used by landscape architects in planning cases of this sort of thing. It's these photo montages give you the impression, and this has been debated quite a lot in the literature, about the truth of what is seen from these different viewpoints. If we look at how these are depicted, we're looking at photorealism, and the content of these images we assume to be the truth or the truthfulness of the situation. Now, I've got a video here with Alan Chenoweth, who's a senior landscape architect and a friend of mine from Brisbane, who explains the research problem that he and Atta were involved in.
When developers propose buildings or councils approve new developments that the community may have concerns about, they can institute an appeal, and the appeal will end up here before the Planning and Environment Court. Now, the costs and delays involved in taking an appeal to court can be substantial for all parties involved. In Queensland, the Planning and Environment Court manages these appeals very closely and reduces the time and the costs involved through the use of expert witnesses who meet jointly and resolve as many issues as possible before the court convenes. In court, there are at least 2 parties to an appeal, the appellant and the respondent. They're represented by barristers who would normally sit here. The judge will make a determination on each appeal based on the evidence presented, and that is mainly the evidence of expert witnesses in the Planning and Environment Court.
So we'll leave Alan there. The point that I want to make here is that I believe that these photo montages are positioning the producer of them as the expert and the viewer as understanding observable reality, much like what we were saying about the drawings in the classroom. There's a lot of similarities between the classroom and the courtroom. Both are decontextualized from the reality, the real world reality of what they're discussing. Now, what Atta's doing over here to the right is he's looking at a new technique called the visual bowl. So if you position yourself as a viewer here, what he's suggesting is that instead of looking at just what a photo montage can do, he's looking at how to map the heights of all of the developments in a 360-degree view. So over here, he's actually plotting out the elevation of what's around him, and then he's putting it into a plot. So along the x-axis, we have 0 degrees to 360 degrees. And on the y-axis, we've got the elevation angle, or the height of these buildings and vegetation. And you can see where the field of view is normally for an observer, roughly 124 degrees horizontally and 55 degrees vertically. And so that's what an observer would see. And that's what is usually represented in photo montages looking through a camera. But in this technique, what he's doing is trying to represent what is consistently around that viewpoint. And he's looking at it before the development goes into place and after that development goes into place. And you can see in the time span when these other developments come into play, that the new development isn't an anomaly within the city skyline. It's actually sitting with other developments of similar or greater height. Now what this does is it shifts the position. It shifts the position to being located more in the social space in society, in my humble view. And it allows these plots to speak to everyone, to see the situation rather differently from a 360-degree point of view. So here the producer of these plots is being positioned more as a guide, and the viewer can make their own decisions from the data represented. So that's a kind of a slightly different technique to use in these courtrooms. So we're trying to publish that this year. Now we shift to something very different, and this is videography and moving images. And I did quite a lot of work with a film director and a cameraman out in Brisbane to try to develop videos that I could bring into the lecture theatre to illustrate theoretical concepts of landscape ecology to students, so that when they went out onto the site, they could actually see the site, the real world, through the lens of these abstract ideas. And this is just one video that I randomly picked to just illustrate what I meant.
So this boundary becomes an active transitional space, and part of building community identity is this building here, and this building faces this way, but also it faces this way towards the bushland. That means that both sides then are valued by local people.
So what I believe is happening here is that the teacher is being, because the teacher appears in the video in the context which the students understand they're going to be going out to study, then it changes the dynamic quite a lot. The teacher then is positioned as more of a facilitator, and the students then understand that they can develop their own capacity for being able to interpret what they see around them in an abstract way. And that's really important because you're then shifting the position. They're seeing things in a very different perspective. This video of Laura.
So this is the next tree, Photinia crossfraserae robusta. So let's have a go at saying that. Photinia crossfraserae robusta. And you're probably familiar with Photinia more as a hedge than other things. It's really common as a hedge, but it is a small evergreen tree. It will grow to.
So what Laura's doing, and we've done this for many years, is taking the students around Lincoln campus and showing them plant material, giving them the botanical names and common names that they have to learn, giving them the information about their diagnostic features, their growing conditions, and their maintenance requirements. What's interesting about these videos, and we've only just started doing it this year because of COVID-19, is that the students don't seem to take what they've learned. They pass the tests and whatnot, but they're not then using that knowledge in their planting plans within the classroom. So what I'm starting to think now is that what I need to do is I need to position Laura not just as an instructor and the students learning what she tells them as professional knowledge, but more as a guide in terms of how they use these plants in their planting plans. So we haven't quite mastered what has to go into this particular course at Lincoln yet. But I think it's really important to see that even though the students are learning this information out in the real world context, they're not yet bringing it into the classroom to use it in their own work, which is really interesting. And it shows how contextual learning is. Then we move on to immersive 3D environments. Now, this visualized representation of Brisbane City is done by a company called AI3D, which is run by a former student of mine. And they do the most amazing representations of new developments and places and spaces for clients all over the world. They don't really like this image because it's a model in development. I love it because you can see how this three-dimensional world is being put together. So you've got the drape of a flat image over a flat plane for the botanic gardens in the foreground, and you can see how much easier it is to actually do models, these kind of geometric models for buildings, than it is for landscape work. But what's important here is that I think these three-dimensional environments are doing pretty much the same job as photo montages. The more realistic they become, and the more you can move through these spaces, the more I think these are very similar to what we were looking at with the still images. I don't think they're actually doing anything extra. However, the power of these environments is that we can actually produce things that create a place based on changing conditions. So you can model increased water levels with climate change, flooding, you can have bushfires, earthquakes, and you can start looking at how these places might have to adapt to these changing conditions. So now we're into the territory of creating future scenarios based on different levels of risk. Before I go on too much further, I might just explain some of these terms that we use. So virtual reality is usually understood as a complete environmental simulation. So people wear these VR goggles, and so visually they're completely immersed in that world that's been created, that synthetic world. Augmented reality is where you have real and virtual objects coexisting within the space in real time. So Pokemon Go was a really good example of this. People knew that they were sitting in a park, but they also were interacting with these virtual creatures. Mixed reality is where real and virtual objects merge to produce new visualizations or new representations in real time. And so we're just starting to kind of think about how that might work in an educational context. And then you have extended reality as well, which is where you have any environment where real and virtual objects are combined through human-machine interactions. So that kind of encompasses virtual reality, augmented reality, and mixed reality altogether. So a couple of years ago, we bought in our department a VR studio, and we tested it out with students to see how they would respond by introducing them in the landscape planning studio that we run at Lincoln. And our senior tutor, Marcus Robinson, set up a model of French Farm Bay so that the students could actually drive the VR model to different viewpoints to see the visual impact of a particular development in this outstanding natural landscape. Now, there are a lot of limitations. We never have enough time to actually spend on developing these models. The students had to learn how to drive this particular apparatus, and they're also standing up in front of the class, as you can see here. So there are a lot of things that kind of didn't work too well for us. But I think if we experimented with sitting students down around a table, so you're seated so that there's no chance of being embarrassed by doing something silly in front of the class, and the VR model was a lot more refined, and there was less ability to have to learn to drive the thing, then I think you would actually start to see the possibilities of virtual reality in terms of students being able to drive it themselves and then learn at their own pace. So the teacher then becomes more of a facilitator, and the students then develop their own capacity to see the visual impact of a particular development, much as they do in commercial practice. And Ian Bishop and many others in the visualization space have done a lot of work on landscape perception in this area. This is a project that I worked on back in Brisbane, which was about developing an augmented reality story for an app. And so this was part of a workshop that you're looking at here with school students and landscape architecture university students on thinking about how we could tell the story of landscape architecture for our 50th anniversary. And so this is what we came up with. Through a series of workshops with local creative artists, we came up with a story that was then uploaded to the Story City platform. And each of these green pins in the map on the right are different stories that were told in a Brisbane setting. Ours was called Master of Time, and it was located next to Queensland University of Technology in the City Botanic Gardens. And the idea was that you go to one of these GPS location points and you can have a look at a visual representation that starts you on a journey. And so you move from one location, represented here by these red triangles, that take you on a narrative through these different points through the gardens. And this is augmented reality here. So this is where you're standing in the real world and you're looking at your screen and engaging in a really interesting story. And this is what some of the videos out of 6, I've just selected 3 to show you.
You're doing one of your least favorite things, waiting, but you've got no choice. This morning you received a mysterious message from an unknown number. The answers you seek lie where time slows down. Your guide will meet you there. People from a
So the idea isn't to be too explicit with what you have to learn. It's about engagement. And this was targeted at young people, and it had to be a narrative that the general public would be interested in. And we kind of broke a lot of rules here. AI 3D did all of the animation for us. And what you're seeing, particularly in that lower image, is what you can't see when you stand on site. So a lot of the videos that we produce had the foundational principles of landscape architecture built into them. So the notion of ecology, of seasonality, of cultural heritage, of Indigenous significance, of narrative going through a place, all of these things were embedded in a more tacit way. So that people would be both entertained and informed. I think augmented reality is super exciting, to be honest, because the strength of it is in taking what we do in the classroom out into the world. That's the big difference. Instead of bringing information from the world back into the classroom, students can then use this as a way of making their own decisions about where they go and what they learn, and they have the chance to actually sit and reflect on what they're actually doing and what they're seeing. So this teacher here, depending on how you develop these resources for augmented reality, can be positioned as a guide or as a provocateur. So we're shifting into those lower two quadrants that we talked about before. We're actually asking the students to see themselves and question their values of the way of being in a particular place. So that's augmented reality and some of the things that we were doing there. Now, mixed reality is the next step, if you like, slightly different. This is a piece of equipment that we bought called the AR, or Augmented Reality Sandbox. And Marcus and another colleague on our team, Don Royds, set this up so that we could experiment with this particular device to show students how three-dimensional contouring can change the form or the landform of a particular site. We haven't spent a lot of time experimenting with it in the classroom. We tend to use it for school groups coming to see us. It's got a lot of potential, but I see it as something that's very similar to virtual reality and the videography work that I've done, in that you're bringing the world into the classroom. So there's a focus on place in a broader abstract concept or setting here, and it's driven still by social norms. So in this case, it's map making. Now, the reason why it's mixed reality is because what you're doing is you're merging the sand, the real object, with the virtual object. So what's happening here is that the projector is projecting this interactive image. The sensor is reacting to the change in levels within the sand that we're modifying. And that's why it's mixed reality, because you've got the two converging there in real space and real time. And so being able to experiment with that is something that I would like to do a little bit more of. And here I think the teacher is more the guide, and again it's the students who are the decision makers about possibly the earthworks when they're designing a site. So that's an interesting thing that we still have a lot more to do to play with. This is the project that I've been working on up at Kuratawhiti Conservation Reserve, or most people know it, I believe, as Castle Hill Rocks. It was our attempt to look at photo montages and survey New Zealand domestic tourists, which are kind of hard to find because they're only about 30% roughly of the people that actually come to Kuratawhiti as visitors. The other 2/3 are international visitors. So trying to find the New Zealanders out of all of the visitors that come here isn't a very easy thing. But we got about 150 participants for this study. And what we did here is Yu Ching, one of our PhD students, created these 4 photo montages. And what we tried to do was ask New Zealanders to think about, if Kuratawhiti had much greater tourist pressure in the future, what sort of design interventions would be acceptable to them? So you can see here we looked at signage, we changed the different signs. We looked at fencing, we changed the fencing in each one. We looked at edging and widening and straightening the path. So these sort of interventions were interesting from a design point of view. In terms of what the participants said, I think because the image was so tiny on their mobile devices, that what they generally just saw was the increase in numbers of people. And not surprisingly, that's what they reacted to. And so the results show that they prefer not to see so many people in this particular setting. But what's interesting, at the moment, I'm working with one of our MLA students, Aria Huang, who's looking at other visual techniques or representations to think about how we might engage the general public in these kinds of information gathering exercises. And here I think what we're trying to do is position viewers, or in this case New Zealand tourists or visitors, as decision makers in the design process. What's very interesting is that Aria has found that because Kuratawhiti has cell network coverage, there are quite a few people that have uploaded not just their still images, but also their videos and their 360-degree views from these rocks. That really interests me because we're moving into the space of public participation GIS. And the potential of this from a learning and teaching point of view, I think would be very interesting. So that's about where we are. That brings us to kind of global trends and changes that I kind of forecast or can see happening in landscape architecture. I won't go through all of this in great detail, but what I do want to do is come back to the model that I introduced you to before and think about where some of these tools might fit in the pedagogic code that we were talking about earlier. I think if you look at the top right-hand quadrant, this is where drawings, still images, photo montages, static models might fit. And in the future, I see the potential for students to program machines to actually do this kind of work for them. So we know that a lot of more mundane kind of jobs can be done more and more by robotics. Now, I know this is not going to make some of my colleagues very happy, but I do think that there will be potential for students to, in the distant future perhaps, to actually get machines to do more and more of this kind of work. If we look at the top left-hand quadrant, this is where I think videos, virtual reality, and any other web interactions through the 5G network could actually take place, because this is where students get to progress at their own pace through their learning. And I can see down the track, this is where students may actually be demanding personalised curriculum design for each of them. Now, that's maybe way down the track, but I can certainly see from personalised medicine that this is the direction that this may be going in. Finally, not finally, down on the top, the bottom right-hand corner, this is where I think gamification, and if any of you saw Mirko Geralda's presentation last week, he talks about online gamification of his curriculum. This is where I think this fits. Augmented reality, mixed reality, and public, or we could say student participation GIS is where this might fit. So any extended reality that allows learners and teachers to work on mobile devices anywhere, anytime would be where this fits. And then if we go to the bottom left-hand quadrant, where students would have complete control over their choice of what they learn and how they learn, students, this is where gamification with avatars, simulations might work, where students start to reflect on who they are and where they sit and where they fit into the world. And there is a possibility that I thought of where university campuses could actually design classrooms around content. so that each classroom students could go to, access through face recognition, and participate in a class that is constructed around resources that give them content that they select themselves to actually learn and participate in. Instead of the classroom being associated with groups of students, the classroom is then kitted out with equipment and with content that is something that students could choose to do. But I'm sure that's way down the track. So this has really tried to give you something to kind of think about, whether you agree or disagree. I'd be interested in knowing. These tools are changing very fast, but the educational settings and contexts are very slow to change. I think we should be trying to better understand how these tools can work in education. There's not a lot of us that are interested in these kinds of topics, but I think more and more we're going to be challenged to think about how we embed them in our curriculum design. We've talked about drawings, still images, videography, moving images, virtual reality, augmented reality, and mixed reality. We're very familiar with how to deal with drawings and still images because we've been debating and talking about this for a long time. Videography and moving images is something that the entertainment industry is very familiar with, and they've written books about cinematography and so on. We're not so familiar with it in the educational context, and I think it has some huge potential. Virtual reality, augmented reality, and mixed reality can be very costly in terms of time and money. So we really want to know whether we're going to actually get a value for money in terms of our investment in some of these technologies. So experimenting and theorising with them, I think, would be very valuable. And so today you've seen my attempt at predicting pedagogic code in a changing visual world with these new tools starting to become more and more available. So that's it from me. Thank you very much. And these are just some of the things that I've been publishing in this area.
Thank you very much, Jill. I can hear myself in your computer.
Sorry.
So if you guys can please start posting your questions so Jill can answer them. So there's the Q&A box on the top, on the right of your screen. If you can write your questions there, and I will pass them on to Jill. So thank you very much, Jill, for your very interesting talk. It comes at a really interesting time for education, with COVID-19 being still around and us being back in level 2 for those of us in the South Island and level 3 in Auckland. You know, these technologies should also help us in transitioning towards a different way of teaching and doing more online teaching as well. How has been your experience with that so far?
Well, as I said, it's kind of mixed. So we've only been really dabbling in some of these techniques. Videography has been my favourite so far, and augmented reality is probably my next favourite, but that's a lot more complicated to put together, whereas videography offers the academic the chance to do a lot of it themselves. You just need a bit of training in terms of how to set up the camera and shoot the action, and then how to do some post-processing. So I've been able to do 50 videos of Laura, for example, around the campus to help our students in remote locations fairly quickly. But these other extended realities are a lot more difficult to actually put together.
Thank you. We have a question from Anne. Thanks, Jill. Very interesting in terms of designing public participation. Lots to digest. I'm interested in your thoughts about how this could work with collective / peer-to-peer decision-making in communities or design studios, rather than individual or expert-to-student decision-making.
Anne. So the closest thing I've done with that is to work up at probably Kurutawhiti, and this is where we're at the moment. So I don't have any definitive answer for you. I do think mobile devices could actually be a great way to collect community input, but you would still have to probably have the services like yourself to be able to interpret and kind of filter that information into something that's usable to work with designers on landscape architectural work.
Great. I have a quick question for you, Jill. So we talk about these, virtual or visualization tools to help us, understand or look at the landscape. It actually allows for more remote remote assessments, like the VR goggles. When using it in landscape planning courses, it really opens up the whole perspective of understanding what a visual impact assessment could be and how it could actually shape future decisions, especially with the new ratified and updated RMA. But also, having the physicality of the sandbox, for example, and seeing really in terms of topographic lines and the shape of the land and how landform can be manipulated, let's put it this way. Have you looked into physical models per se?
No, I have to admit that I haven't done a lot with physical models, but I would, because they're static and they're very similar to what I would see as drawings, still images, photo montages, even those 3D representations that I was showing you before. I haven't really looked at physical models per se. They can offer some interesting opportunities, especially for first-year students that are starting on developing their spatial understanding. But they're limited in terms of how much change you can kind of impart using those static images. But it's the same kind of relationship with models that you have to drawings, because you've got that tangible human brain to something physical that you can interact with. But more and more students are actually picking up the digital side of things as their reality. So I'm not sure whether physical models will actually I'm not sure whether augmented reality or virtual reality models will actually do anything very different to static models, if that makes sense.
Yes. Yes, thank you. Well, thank you very much, Jill. And thank you all for attending our SOLA seminars. We will be taking a 2-week break because it's mid-semester break for the Lincoln University crowd. We will send you a new updated seminar session in a couple weeks, and we will see you then. Thank you all very much and have a good day.